This begins WE 555 on Thursday, April 24, 2014.
Thank you very much. Good morning, everybody. Okay, let's continue our discussion, try to wrap up the material on optical networks. We started looking at alternative architectures of deploying optical technologies we started first of all in the core network. We'll get to the access network in just a second. Two alternatives we discussed last time. The first one is deploying IP over DWDM directly. So we have a bunch of routers. All of these are IP routers, and they are connected to the wavelength division multiplexer. This is the wavelength division multiplexer directly over the optical transmission. No need for switching involved. In here we do have, for example, in here we have point-to-point connectivity between the POP, the point of presence, the first point of presence, second one, third one, and fourth one, and so on and so on. This is called what? This is called routers connected via the WDM link directly. In this case here, the routers are connected via reconfigurable optical cross connect. OXC stands for what? Optical cross connect switches. Optical cross connect switches, which means what? It means they don't have, the routers do not have the wavelength division multiplexing interfaces. They are connected to the switch, and the switch will be what? Will be directing the traffic from this point to this point, and so on and so forth, from all over the place in the optical domain. When we say optical cross connect switches, in the optical domain. We studied those last time. We looked at the pros and the cons for each one of them. Of course, this one is preferable because it reduces a certain layer, a single layer of processing. And instead of having layers between the DWDM and the IP, and this one is directly over. So it's one layer less of a processing. However, this one requires the routers to have high interface, when I say high rate interface, which means what we are talking about in hundreds of gigabits per second. There are routers currently, some of them are from Cisco, some of them are Juniper, that can support 100 gigabits per second, but it's not all over the place. The higher the rate of the interface of the router, it means what? It means the router will lose a little bit of the performance because it will be what? It will be sending the packets too fast, which means what? It's going to be what? It's going to be exhausted. Let's put it this way. So the amount of traffic that is going to be done. Now the intelligence, again, as I told you last time, the intelligence is residing in the POP, in the router, in the IP router. This is where the quality of services is going to be provided, the monitoring of the traffic engineering, and so on and so forth. Provision of provision of the bandwidth available, and so on and so forth. This one will be strictly a what? A transport mechanism. Then we looked at, in general, we looked at deployment, optical deployment, in everything. Most of the deployment currently, most of the deployment of the optical is in the core network. But the trend is starting to get back into the metro access and in the customer access. Not every customer like you and me have just a little bit. There are big customers For example, here, a big institute, like, for example, at USC or something like that, big institute or a residential community that they do have aggregated traffic, they use XDSL to connect to to connect to the neighborhood node, and then the neighborhood node is connected via optical fibers all the way to the metro link and to the metro network and to the core network. The metro networks, these are the metro networks. Most of them are based on what? On ring, SONET rings, like I showed you earlier in the discussion. SONET ring. In the core, some of them are SONET rings, and some of them are what? Mesh type. This is a mesh type topology. A mesh type topology. This is a ring topology. So they do have combination of the two. Now, let's look at the optical deployment in the access network. In the access network means what? Access network from customer network to service provider office. From the customer network to the service provider office, which means what? It means this one. This part. By the way, some of them are even wireless. Look at these. These are all wireless or cellular equipment communicating with what? With the telephone network. With PSTN, and the PSTN are what? Part of the PSTN is connected to what? Is connected to a SONET ring. See this one here? The traffic is going to be aggregated from multiple what? Multiple devices. Actually, these devices are communicating with a base station. With a base station via radio. But then the base station is connected to the telephone or to the POP via what? Via SONET rings, different SONET rings, and so on. So we'll see how we provision the traffic in just a second. So the access network is what is referred to as the last mile. Sometimes they call it the last mile. Connect the customer or the business or residential network to the what? To the provider central office. The access network always constitutes the what? The bottleneck. Why? Because the capacity or the bandwidth that is available in the core is much higher than the one that is available in the access. So it constitutes the bottleneck. The backbone, for example, provides 10 gigabits per second or higher, whereas the access, if you use DSL or if you use cable, provide 1.5 megabits per second, 10 megabits per second. So that is the trend. Currently, what we have is what? Most of the residential customers have what? Either DSL or have what? Cable. At what rates we are talking about? We are talking about rates roughly in this range. Whereas the backbone can support how much rate? 10 gigabits per second. So the bottleneck will always be in the what? In the access network. So they said what? They said, can we deploy the optical fiber network on the access, in the access also? In other words, to the customer, the fiber to the customer, and instead of what? Instead of them using DSL or cable. So the next generation, they are looking for deployment of the fiber in the access network. Some of them are referred to as what? FTTH. FTTH stands for fiber. FTTH stands for what? Fiber to the home. FTTC, fiber to the home means what? All direct fiber directly goes to the what? To the home, which means in your home, you need to have an optical interface. An optical interface, interfacing your equipment at home with the what? With the fiber that gets to your home, which I'll show in just a second. FTTC is what? Fiber to the curb. What does this mean? Curb means what? Means the neighborhood. So they extend the fire all the way to, not the fire, they extend the fiber all the way to the what? To the neighborhood curb, and then from the curb to the what? To the residential via what? Via cable or via what? Via DSL. Clear? So in other words, they get the fiber as close as possible to the resident, but not to the resident exactly, which means the resident does not need to have a what? An optical interface. The curb, the node at the curb needs to have an optical interface. FTTB stands for what? All of these are variations. Fiber to the what? To the building. A business building or something like that, to all units in a building rather than just simply a home. All of the above solutions, as we will see in just a second, are based on the architecture which is referred to as a what? PON, which is very important to understand. It's called what? The passive optical network. Passive optical network. We will see how it works in just a second. Oh, this is a generic. This is a generic. In other words, it's whether it's to the home or to the office and so on and so forth. What you have is what? We have a bunch of users in here. And then we do have what? We do have network interface units. The network interface units are either located at the homes or located at buildings or located at what? At the curb. So the locations of the NIU will determine what type of deployment we have. So we have a bunch of users and we do have what? Network interface units, again, located wherever the optical interface ends. Okay, then we do have what? We do have remote nodes. These are remote nodes that collect traffic from what? From the hubs and what? Exchange it to all what? To all, deliver it to all the users all over the place. So you do have what? From the hub is where this is the central office. This is in the central office, the service provider. The service provider will what? Will feed the signals, the optical signals to all of these remote nodes, and the remote nodes will what? Will distribute it to the network interface unit, to different network interface units. This is a generic. Generic means what? Means it does not depend on what, whether it's FTTH or FTTC and so on. So it's a generic architecture to see how the user network and the user network and the service provider network are interconnected. From here to here, we call it what? Feeder. From here to here, we call it what? Distribution. In here, you are feeding the nodes. In here, you are distributing it to all what? To all the customers. Oh, so you have this, for example, if you look at this, this is fiber to the home all the way. This is your home. This is your home. You have a what? An optical network unit. An optical network unit and an interface. Network interface unit. All the way attached to your what? To your home. Your home. Your homes are connected to the what? To a remote node, another remote node, another remote node. When you see this, do you see this one here? This one means what? Distribution to what? To multiple homes. Did you get this or not? Distribution to multiple homes. This is all the fiber to the home. What is this? This is fiber to the building. So we do have a what? A residential build, not a residential, sorry. A business building here. All multiple what? Multiple units. Multiple units. And the what? And the ONU is attached to the what? To the not to your home, but to the building itself. That's the optical network unit here. And it's also connected to what? To the fiber nodes. To the remote nodes. All of these are fiber nodes, actually. But remote, the reason that we call it remote is that because remote from the hub, this is at the central office. By the way, look, at the central office is providing all types of services. Interactive video, digital TV, high-definition TV, telephony, remote games, internet access, and so on and so forth. All of these are provided where at the service provider. This is what? This is to the curb. So we have the FTT to the curb. So we have cabinets or no. You see this one here? This is the remote node. Here, this is the curb. The remaining part from the curb, this is the curb, the neighborhood. From the neighborhood to the homes, you do have what? DSL or what? Or cable TV. In other words, what I'm saying is that this part is not fiber. This part is not fiber. But this one is what? From here to here is all the way what? Fiber. Clear? The last one here is what? It's, in other words, the home in here, when I say network interface units, these are not optical network interface units. These are what? DSL interface unit or what? Cable interface unit. The optical interface unit is what is in this at the curve. Clear? Here also we have what? But what do we have here? We have homes that are equipped only with what? Wireless connection. An example of which we will discuss when we get to the wireless is the WiMAX. The WiMAX is a service where it can provide wireless service to the home. They are communicating with who? What is this? This is a base station, some kind of a base station. So these are all what? Wireless. And then this one and this one are connected to what? These are cellular, by the way. This is your cell phone. And this is what? The base station in your, where you are talking with. Did you get this or not? The base station is attached to what? is attached to the optical network unit via fiber all the way to the remote nodes and to the hub. Clear? So whether the user is using wireless equipment or whether he is using fixed equipment, still the possibility exists that you would have a fiber in the access network. Clear? Might not be the immediate one. The immediate one is radio frequency, but from the base station you are going to have what? You are going to have fiber all the way to the remote nodes. Clear? Clear? That's the way it is deployed in the access. By the way, once you get to the hub in here, when you get to in here, this is what we were talking about a moment ago, which is what? Which is the metro rings, the SONET rings, for example, or the core, the mesh core. This is only on the access type. Clear? Okay. Now let's look at the passive optical network technology. This is the passive optical network. Now, what did we say in a passive optical network? Passive means what? There is no changing to what? Electrical. It's still optical. A passive network, when we say a passive optical network, I want you to see the difference between this one and this one in here. This is a what? This is a multiplexer. They are sharing the same what? Users share the same what? Same power, same share. When it gets to the what? To the node, this is the remote node. The remote node will just simply what? Split the power. This is what we refer to as what? As a passive coupler. It split the power. Notice, by the way, in here we have what? For example, in here, what is this? I cannot read it. It's not very clear. But in any case, the power is split at this node here to several customers. So all of the customers are what? Are using the same what? Are sharing the same resources in here. I want you to see the difference between this one and this one. This one is a DWDM, the wavelength division multiplexing. In here, every customer is going to get what? Is going to get a single what? A single wavelength, which means what? The wavelength is dedicated to a what? To a customer. This one is wavelength division multiplexed, but they are not sharing it. They are not sharing it because each one of them is dedicated to what? To one wavelength. Whereas this one here is what? Is not. They are what? All of them are sharing the same what? Are sharing the same wavelength on this side. Did you get my point or not? Did you get the point or not? Okay. Now, if you do have what? If the users in here share the power and the land is for users or services, for the entire users or services. So we do have what? Multiple wavelengths in here. But they are not what? They are not dedicated. So we do the what? The power splitting, but they are not what? They are not dedicated. Whereas here is dedicated for use. The land, for example, this one goes to here. This one goes to here. This one goes to here. Dedicated land per users. Additional, we can also have what? Additional broadcast overlays. Broadcast means what? Some wavelengths that are used specifically for what? For a broadcast, which means what? To all users. Clear to all users. Some of them are dedicated, some of them are what? Used for all, as a broadcast overlay. Overlay means what? You are overlaying the broadcast services on top of what? On top of the dedicated service. Clear? Did you get the difference between WDM and the passive optical network? In a passive optical network, there is a what? There is a single wavelength in here, and it will be what? Split. The power will be split. Whereas in here, there are what? Multiple wavelengths, and the wavelengths will be what? Each wavelength will be dedicated to each one of them, as I will show you in just a second. Okay. So, for example, if you look at the passive optical network, what do we have here? This is a central office. This is a splitter. This is where the power is going to be split. So we have what? We have, this is a single fiber. The power will be split into how many ways? Into 8 to 16 homes, which means what? 8 to 16 ways. All the way to the home. This is what? To the home. Service to the home. The home has what? Optical network unit. Every home has an optical network unit. G here, G stands for what? Gateway. The home gateway, which performs the multiplexing, the demultiplexing, the address resolution, and so on and so forth. What does address resolution mean? Listen to me. When this one is arriving in here, what is this one will do? It will split the power. Clear? To all of them. Now, some of traffic is destined only to this one. Well, this one gets it. This one will get it. Why? Because this one is just splitting the power. But in here, in the gateway, there will be a what? An address resolution. Address resolution means what? You check the header of the packet to see if this traffic actually is what? Is destined to you or not. If it is not, then it's what? You just reject it. Clear? Clear? Okay, this what means what? All of them, are they all receiving the same information? They are all receiving the same information, but reduced what? Reduced power. Clear? Reduced power. More users here, the less power that they will be able to receive. Now, this is a what? This is the fiber to the home using wavelength division multiplexing. Let's understand what we have here. We have a central unit here. These, each one of them, see this one is receiving at what? Lambda 1, this one at what? Lambda 2. Lambda 1, let me ask a question here. In here, this one and this one and this one, on the uplink, can they transmit using the same wavelength? Do we need medium access control procedure? Yes, we need medium access control procedures. Why? Because if they attempt to transmit at the same wavelength, what will happen? This one there will be what? There will be collision in here. So there must be a what? A medium access control procedure where the central office will control which of these homes will be what will be transmitted. Now look at using the wavelength division multiplexing and fiber to the home. This one is not as advancedly deployed as this one. Currently, this one is deployed more than this one. Did you get this one now? Okay. What is this one in place? Listen, see, every home, this one is going to be what? Receiving at a certain wavelength and transmitting at a what? Another wavelength. So this one receives at what? Lambda 1, transmit at lambda 2, lambda 3, lambda 4, lambda 5, lambda 6. What is this one doing? On the uplink, this one is behaving as a what? As a multiplexer. On the downlink, it is behaving as a what? A demultiplexer. So on the uplink, what do you have? Lambda 2, lambda 4, lambda 6. Is there collision? No collision here. Do we need medium access control procedure? We don't need medium access control procedure. What we need is what? We need more wavelengths. We need more wavelengths. Are you following? So in this case here, for example, this fiber needs to support how many wavelengths? 6 wavelengths. 3 on each side. 3 on the downlink side and the 3 on the uplink side. But is it a single fiber? It is a single fiber, but it is supporting what? Multiple wavelengths, like I will show you in just a second. Clear? This one here will be demultiplexed as going to the what? To the central office, back and forth, and so on. This is in the access network. In the mesh network, in the metro mesh, means what? Means after you access the central office, in the mesh network, most of them, again, as I told you, either a ring or are what? Mesh, and they are all using, do you see these? All of them are what? Are optical cross connect. If you are running, if the technology used is what? Is IP router over what? The optical transport network. If you are running over what? DWDM, then the routers will be attached to the what? To the multiplexer directly. Currently, most of them are running over what? The routers are all connected via what? Via optical cross connect. See, optical cross connect, and so on. Clear? This is in the metro. This is what mesh. This, and so on, so on. Clear? Okay. Okay. Now, one final thing before we leave this set of charts to show you how we assign the wavelength is the notion of optical switching. Currently, most of the switches are what? Are electronic switching. Electronic switching means what? Means that the signal is going to come over the fiber as an optical signal, is going to be converted to what? Electronic signal, is going to be switched electronically. Is going to be switched electronically and then converted back to what? To optical signal to be transmitted over the next span of fiber. What they are proposing or what they are working on is to have what is known as what? Optical switching, which means what? Everything will be done in the what? In the optical domain, rather than what? Rather than changing it to electrical. Now, in an optical circuit switch, most optical switching currently is circuit switching. What is the meaning of circuit switching? From port 50, in a circuit switching, the circuit is going to be what? Established, and it's going to be what? Dedicated for the duration of the call. The duration of the call. So what do we have in here? The optical, again, currently most of them uses OCS. OCS stands for the optical circuit switching, optical circuit switching. This is a switch here. This is the controller becoming different what? Different type of what? Different type of wavelengths. This is, for example, lambda 1 and so on so. Now, one of the lambdas also is called what? Out of band switch control. This is only for what? Controlling the switch here. We call it what? The optical supervisory channel. One of the channel is dedicated for what? Optical supervisory channels on a different wavelength to control the what? To send control signals to the switch. Control signals means what? Signaling, for example. Clear signal. When you do circuit switching right now, you dial a number. Here, what I'm saying is that here, all of this control signaling will be over a what? A separate wavelength, rather than the wavelength that you are using for what? For your data. The lambda 1 is going to be used for your data, but this one here is going to be used for signaling from one to the other. Most of the switches currently are what? Are 2x2 optical switches. Remember I showed you previously, if you want to build a switch, let's say 16x16, you will design it in what? In modules. Every module is what? 2x2, 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 and so on so. Where is this one going to go? This one is going to the other switch, to the next switch, and so on and so forth. The control is separate from the what? From the data. The control is separate from the data. This is an inefficient utilization of large wavelength channel capacities, because the circuit, again, as I told you, is dedicated. When you say circuit, it's dedicated for the duration of the call. So if you are not having anything to transmit, the wavelength is what? It's wasted. The wavelength is wasted. Wavelength is dedicated to you. Clear? The packet optical switches, which is less used than this one, but the hope is that this one will take over. The packet optical switches, what do you have? This is the switch. These are, again, the input buffers and the what? The output buffers. Again, most of the switch are what? Are 2x2 switches. Incoming packets, these are the packets usually introduces what is known as what? Statistical multiplexing. This is for packet switching. Statistical multiplexing in the what? In the optical layer. In the optical layer. Optical layer means what? The physical layer. Switching of optical packets. Optical packets are roughly between 40 to what? 1500 bytes long. So it's not very long packets. In band, which means what? It's the same wavelength that is used for what? Control, for switch control, and for what? For the actual data. You are not using different wavelengths. This is on the same wavelength, both the header and the what? The payload. This is the header, the payload, the header and the payload. The header will what? The header will be processed in here to determine what? The switching connectivity. You don't send these on different wavelengths. In here, in the previous one, control signaling is done over a separate what? Wavelength than what? Than the actual wavelength that is used for data. In here, no. They are what? They call it what? In-band. In-band means what? The same wavelength. Switch control using optical packet headers. Requires the switching speed in what? In nanosecond. Because it's extremely fast. The switch has to work in the nanosecond range. Currently, by the way, the problem with the optical switching is how to buffer the packet in the optical domain. How to buffer the packet in the optical domain, which means what? The input buffers here and the output buffers here. Currently, optical buffering requires bulky and lossy and expensive devices. Currently, the OEO convergence required for electronic header processing. In other words, for the header, currently they use what? They use OEO. OEO stands for what? Optical optical convergence. For the header. For the payload, they are going to switch it in what? In optical domain. Clear? Only the header will go through what? Through the processing, switching, synchronization, and so on. And finally, they have a new thing which is called what? Optical burst switching. In optical burst switching, they don't need buffering. See, they remove the buffering, but require that you send a what? A burst control packet. Before you send your burst, you send a what? A burst control packet to PCP stands for what? Burst control packet, which is what? In band or out of band. Both of them are used. In band or out of band switch control using a burst control packet transmitted ahead of the burst. You transmit this ahead of this to alert that what? What is the size in here that is coming, and so on and so forth. so that you don't need to have what? You don't need to have a buffer. When the burst comes, the configuration is already set to what? To switch it to the other side. Clear? Okay, but this currently is having difficulty in the deployment here. You notice, by the way, the burst is much bigger than this burst is much bigger than the previous one. We are talking about what, tens of kilobytes long types of burst. Clear? Aggregated burst. There is a time offset between the burst control signal and the actual burst coming. Clear? Clear? Okay, good. Now, one more thing to discuss before we leave the optical altogether, which is what? Which is how we are going to allocate the flow and the wavelength in sonnet rings, which is very important. Okay, so let's understand. You will see something like this in the final exam. So I need to make sure that you do understand it carefully. In the final exam, I'm not going to ask about burst switching or packet switching, something that is not deployed all over the place. But this one is, so you need to understand it. What we have here is 4 nodes. So for example, 1, 2, 3, 4, and what? And connected by what? By WDM, wavelength division multiplexing. Every wavelength division multiplexing, every wavelength can support, just an example, every wavelength division multiplexing, which means what? Every lambda can support how many, what traffic? OC48. OC48 is what? Is roughly what? 2.5 gigabits per second. Gigabits per second. So on every wavelength, there is a support for what? OC48. Every wavelength can support OC48 the data rate. Now, the question is what? How we are going to assign the channels? How we are going to assign the channels on each wavelength if the customer is requiring OC12. So the traffic is coming from what? OC12. OC12 is what? Is 622 megabits per second. Which means the following. I want you to see this. This is the traffic requirement. What does it mean? What does this 2 mean? Means from 1 to 2, there is a traffic requirement of how many OC12? How many OC12? 2 OC12. Now remember, every wavelength can support what? OC48, which means every wavelength can support how many of these? 4 of them. Did you get my point or not? Oh, you have to get this one here. This will be in the final exam. I will give you this in the final exam, and I will ask you how to assign these channels on wavelengths. So concentrate, please. Every wavelength on here, every wavelength can support how many channels? Can support what rate? 48. Clear? OC48. The requirements in here is in terms of what? OC12. Do you understand what the grooming means? The word grooming. Grooming means what? Building from lower rates to what? Higher rates. Which means what? Every wavelength here can support how many? 4 channels. Clear? In other words, every wavelength can support 4 channels, each at what? OC what? 12. Each at OC 12. Why? Because he tells us that what? That the wavelength can support, every wavelength can support what? OC 48. Clear? So now, what do I have here? I want you to understand the question here. From 1 to 2, skip this one here for just a second. I want you to understand this first of all. From 1 to 2, this link. Who is going to use this link? This link, the traffic that goes from what? By the way, the topology is a what? Is a ring topology. I call it a unidirectional ring. This is that's why we call it sonnet rings. Clear? Unidirection. From 1 to 2, the traffic will go here. How much? Can you zoom in, please, a little bit? A little bit more? Yeah, thank you. Do you understand the gamma 1, 2? What is the gamma 1, 2? Gamma 1, 2 is the traffic that originates from what? 1 and destined to what? 2. Did you get this or not? Yes? Okay. What else? Who else is going to use this? Who else is going to use this channel? This link. It's gamma 1,3, which is a traffic that originates from 1 and destined to what? 3. Who else? Gamma what? 1,4, which is what? The traffic that is destined from what? 1 and going to what? 4. Yes? Yes? Any traffic that originates from what? 2. No. There is no traffic that originates from 2 that will go over this link. Any traffic that originates from 3. 3, if 3 wants to send to 2, will it go over this link? It will go over this link. Are you following me or not? Okay. How about 4? 4 to what? 2 and 4 to what? 3. Did you get this or not? Yes or no? What is the total? What is the total rate in here? What are we trying to determine? We are trying to determine how many wavelengths do we need in here? How many wavelengths do we need in here? Remember, every wavelength can support what? 4 OC12. Did you get this or not? Yes or no? You are losing me here. I'm not sure why. First of all, let's get back to here. You are not getting this. What is this 2? Can you explain this 2 means? What is this 2 means? From node what? From node 1 to node 2, there is a need for how many OC12? 2 OC12. What does this mean? 3. What does this 3 means? From node 2 to node 3, there is a need for what? 3 OC12. Did you get this or not? Okay. This link, who is going to use this link? Which traffic is going to use this link? The traffic that is, in other words, the traffic when it flows. What traffic is flowing over this link? The traffic that originates from what? 1 and destined to what? 2. What else? The one that originates at what? 1 and destined to what? 3. From 1 to 3, does it go over this? It goes over this. You follow me on that? From 1 to 4. Does it go over this? Okay. Here. Why is this one empty? Why is this one empty? Do you see this side? Why is it empty? Because the traffic that originates from what? 2 is not going to go over this link. Why? 2 will send to 3. 2 will send to what? 4. Or 2 will send to what? 1. None of them will go over this link. Did you get it? Okay. What is this? 3-2. Where is this 3-2? 3-2 is this. What is this? 4-2. This. And 4-3. This. What is the aggregate? What is the aggregate traffic in here? Remember, every one of these gamma is in terms of what? OC12. So what do I have here? What is the aggregate traffic here? It's what? Gamma 1,2 plus what? Gamma 1,3 plus gamma 1,4 plus gamma 3,2 plus gamma 4,2 plus gamma 4 what? 3. Yes? Now what is gamma 1,2? What is gamma 1,2? Gamma 1,2 is what? It's 2. Did you get this or not? Yes or no? Gamma 1,2 is what? Is 2. What is gamma 1,3? 1. What is gamma 1,4? 2. What is gamma 3,2? 3,2 is 2. What is gamma 4,3? 1. Did I miss one? No, I did not miss one. Did you get this or not? I added them. What do I get? How many wavelengths do I need? 12 what? When I say 12, 12 what? 12 OC? 12. 12 OC 12. How many wavelengths do I need? I need what? I need at least what? 3 wavelengths on each what? On each link. At least 3 wavelengths on each link. Why? Because every wavelength can support how many OC? 12. 4 OC12. Since I needed 12, then I need what? At least what? 3 wavelengths. Clear? Okay. Now, what about this link? Who's using this link? Who's using this link? Lambda 1-3, lambda 1-4, lambda 2-3, lambda 2-4, lambda 2-1. The 3 is empty. Do you see the 3? It's empty. Why? Any traffic that is generated at a 3 is not going to go to where? It's not going to use this link. Are you following or not? And then what? Lambda or gamma what? 4-3. Gamma 4-3 is what? Is this one. Clear? What is the total? Again, what do you do? 11. How many wavelengths do I need? I still need at least what? At least a 3. A 2 will not be enough. Did you get my point or not? 2 will not be enough. Same thing with what? With this link, and the same thing with this link. Did you get this or not? So the final result is what? On each, what? We need at least 3 wavelengths, 4 channels each. When I say 3 wavelengths, 4 channels. What do I mean by channels? Channel is what? It's OC12. OC12 on each link. Clear? Now, listen to me right now. The traffic that is going from one, this is a multiplex traffic. Did you get this or not? This is a multiplex traffic. All of these are what? Are aggregated. Some of them are going to be dropped in here. Which one? Which one are going to be dropped in here? It's the 1-2 is going to be dropped in here. Which means what? I need to put a what? An added drop box in here. Did you get this or not? To drop some of these and add what? The traffic that is originating from what? From 2. Clear? So what? Which means what? It means I need to worry about where am I going to put what? How many wavelengths are what are needed? We already answered that question. And then how many what? How many ADMs are needed? Where would I put the ADMs? The added drop box. Did you get this or not? Yes? Okay. Let's see if you can help me. Can you zoom back, please, a little bit? Hey, thank you very much. Okay, let's look at the first one. First of all, let's understand the notation here. Let's understand the notation. Do you see these? This is the lambda. Lambda 1, lambda 2, lambda 3, lambda what? 4. You notice, by the way, every one of them is divided into how many parts? 4 parts. Why? Why? Every lambda supports what? OC 48. But the OC 48 consists of what? 4 OC 12. Every one of these OC 12 is referred to as a what? As a channel. Did you get my point or not? In other words, are these all 4 channels on the same wavelength? They are on the same wavelength. Are you following me? They are on the same wavelength, but they are different channels. Clear? Okay. Now let's understand first of all the notation before we get to understand what is the map first means. When you see 1, 2, what does it mean? This notation, 1, 2, what does it mean? It means, so the S, comma what? D indicates the kth circuit from what? S to D. I want you to see this. Do you see what does it mean? The notation. 1, 2, 1. What does it mean? See, from 1 to 2. From 1 to 2. What is gamma 1, 2? What is gamma 1, 2? 2, which means what? We have 2 channels. We have 2 channels. We have 2 traffic channels originating at 1 and destined to what? 2. Which means what? It means I need to use one of the channel to support what? The traffic, the OC12 channel between what? 1 to 2. This is the first one, and this is the what? The second one. Did you get this or not? Did you understand the notation or not? Now, what does this line mean? Do you see this line? What does this line mean? This line means, the solid line indicates the start and the stop of the circuit. Every channel is a what? Is a circuit. So the circuit starts from here and ends at where? Here. Do I need an added drop box here? I need an added drop box here. The question is what? How are you going to assign these channels, all of these channels, such that you would require the minimum number of wavelengths and also what? The minimum number of what? ADMs, added drop boxes. Did you get my point? Did you get my point? Okay. The first one here is what? The first technique is what is known as a what? The channel map first fit. This is the first fit, which tells you what? Stay on the same landing and the same what? Channel. Do not switch channels and do not switch what? Landings. Did you get my point or not? Oh, no, you know you did it. Don't tell me we did. What do I mean by saying switching channels? What do I mean by saying switching channels? Not switching landings, switching channels. What does it mean? It means you go from 1 to what? To 2. Did you get this or not? But it is within the same what? Within the same wavelength. When I say switching wavelength, what does it mean? It means you switch from one wavelength to the what? To another wavelength. Did you get this or not? Yes? Okay, let's see if you can help me. Let's see if you can help me. Let's go back to the required. So look at these. So, can you zoom back, please, a little bit? A little bit back. Hey, I think. Okay. Between 1 and 2, how many channels do we have? 2 channels. This is 1 and 2. This is 1 and 2. Did you get this or not? So this is the first channel. This is the second channel. Are they on the same wavelength? We are multiplexing the what? The channels on the same what? Wavelength. We are not multiplexing wavelength. We are multiplexing channels on the same wavelength. Now, what is this 2-1? Can you tell me what is the 2-1? Here, 2-1. This is the reverse channel. So from 1 to 2, then you need what? 2 to 1. Where is this circuit starting? This circuit is starting from here and terminating at here. Yes? How about the 2-1? How about the 2-1? The 2-1 is the, I want you to see something here. The 1-2 is what? The 1-2 means what? Node 1 to node 2 is what? We do have 2 channels. Did you get this or not? Yes? Okay, good. So, let's see. 2-1. This is this. Where is it starting? Where is this one starting? The 2-1. Start here. Yes or no? Listen to me, guys. I'm not sure you are getting this very carefully. Listen to me. This 1-2, a traffic is originating where? At 1 and destined to where? 2. Whereas this one is destined to where? Is originating at where? 2. But it is destined at what? 1. Did you get this or not? Which means what? When this one comes, when this channel comes from node 1 to node 2, I need to drop this channel and replace it by what? To 1. On the same what? On the same wavelength. Did you get this or not? On the same wavelength. So I have what? 2-1, 2-1, 2-1. Did you get this or not? Where does this one end? This 2-1, where? Where does it end? It ends at node what? 1. Are you following or not? Which means what? Do I need a drop box here? An added drop box here? I need an added drop box here to drop this channel. The one that originates at what? At 2 and terminates at what? 1. I need to drop it. Clear? Okay, good. Now, what is this one? 1-2. This is what? The second channel. And this is the what? The 2-1. Yes? Okay. The third channel is what? What is the third channel? 1 to what? 3. How many channels do we have? Only one of them. This is the 1-3. Where did I start? I started here. Where do I terminate? I terminate in here. Did you get my point or not? Do I need an added drop box here? Now, this, when you see a solid line, do you see a solid line here? What does it mean? I need an added drop box here. Clear? Okay. What is this? These are the 3 to 1. Do you understand them or not? Yes or no? Okay. What is this? 1 to 4. By the way, how many do we have from 1 to 4? We have 2 channels. Are you following me or not? One of the channels will be on what? On which wavelength? Lambda 1. 1 to 4, where will it terminate? It terminates at node 4. Yes or no? Which means what? Do I need an added drop mux here? At what wavelength? At what wavelength? Lambda 1. Yes? And then this is the other way around, the 4 to 1. What is this? 1, 4, 2. Can you tell me what is this 1, 4, 2? From 1 to 4, how many channels do we need? 2 channels. But the second channel cannot fit in with what? With lambda 1. Why? Because the lambda 1 is already what? Exhausted. Exhausted means what? It's all used. So what do you say? 1, 4, comma what? 2. Sorry, 1, comma 4 of what? 2. Which means what? This is the traffic that originates at 1 and it terminates at what? 4. Clear? Answer me the following question. Do I need an added drop mux here? Is it the same as this one or is it different? It's different because this one is going to add and dropping which wavelength? Lambda 2 instead of what? Instead of lambda 1. Did you get my point or not? Okay. Why is this one empty? Can you tell me why is this one empty? This one here. Do you see this channel? Why is it empty? There is no traffic between what? To what? See, what is the goal? The goal is to stay on the same lambda and on the same what? Channel. From 4 to 1. From 4 to 1. What do I need? The 4 to 1. Do you see this 4 to 1? Here. What I'm saying is that in here, do you see why is this one empty? Why is this one empty? Because from 4 to 1 is already here. Did you get this or not? This one is empty. Clear? What does empty means? Means that this channel is what? Is wasted. Did you get my point or not? Okay, let's see if you continue. Why is this one empty? Why is this one empty? It's 1 to 2 already what? It's already covered in here. Did you get my point or not? So this one is what? Empty. What is this? 2 to 1. How many 2 to 1 do we have? 3. So I have what? 2 to 1. Remember, the 2 is what? Originating at 2 and terminating at what? At 1. So this one is what? 2, 1. Why do I say 3 here? Can you tell me why do I say 3 here? The 2 to 1 and the 2 to 1, 2 to 1, how many do we have? 2 of them are already what? Supported on this wavelength. The third one is supported here. Did you get this or not? Okay, so 2 to 1, 2 to 1, 2 to 1. It terminates at what? At node. This node 4. What is this node, by the way? This node 1. It's the other way around. Did you get this or not? So this node 1 here. Okay, now what is this? What is this? This now 2 channel. What is this? 3 to 2. How many 3 to 2? 3 to 2. How many? 2. So what do I have? 3 to 2. Where is it originating? Where is it originating? At 3, which is what? Which is this guy. And where does it terminate? Where does it terminate? Here. In other words, it's like this. Follow me. Did you get it or not? This is the same as this one. Okay, this is the other channel. 3 to 2, 2 to 3, and 3 to 2. 2 to 3, and 3 to 2. Clear? Clear? Okay. Let's see if you can understand this one here. Why do we have this one here? By the way, in here, do we have an added drop mux? Here. Why? Why? Because the channel is destined to who? To node 2. I don't want to drop it at node what? At node 1. Did you get this or not? By the way, so far, how many added drop mux do I need at node 1? How many added drop mux do I need at node 1? 2 so far. 1 is on what? Lambda 1. The other one is at what? Lambda 2. Clear? Let's see if you can help me here. Why don't we need this? What are these? 4 to 2. How many 4 to 2? 4 to 2 is what? Is 4. We have 4 channels. Which wavelength am I using? Lambda 3. What do I use? A 4 to 2, 4 to 2, 4 to 2, 4 to 2. These are the 4 channels. Did you get this or not? Where are they originating? They are originating here, which is what? 4 to 2, 4 to 2, 4 to 2, 4 to 2. And where are they terminating? They are terminating in here. 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 Did you get my point or not? One more time. Where are they originating? They are originating here. Here. Clear? And where are they terminating? They are terminating in here. Do we need an added drop max here? Here, here. Do we need an added drop max here on at node 1 on which wavelength? On wavelength 3. Do we need an added drop max? Why? Because the entire wavelength is used to support the traffic demand from node what? 4 to node what? 2. I did not need any added drop max in here. Clear? Clear so far? Okay. Now, answer me the following question. Do I still need another wavelength? Remember in the here, what did we say? What did we say in here? At least what? 3 wavelengths. I need you to understand, why did I say at least? From the math, how many wavelengths do I need? From the math, just calculating this. I need only 3. So why did I say at least 3? Do you see this at least? Why did I say at least 3? From the math, how many wavelengths would you need? You would need only 3. Why? Because every wavelength is supporting what? It's supporting what? 4. So why do you need at least 3? You need 3. But if you insist that the traffic is to stay on the same lambda and the same what? Channel. Did we switch channels here? No. Did we switch lambdas? No. So we insisted on this. What did it result? Resulted that there is a what? An empty slot here, an empty slot here, a whole bunch of empty slots in here. Yes? We still have one more channel, which is what? 4 to 3. How many 4 to 3? 4 to 3. Where do I support it? Don't look at this here. Do not look at this wavelength. Can you support 4 3? You cannot support 4 3. I'm not sure, did you get it or not? One second. Do not look at this wavelength. This is what you have. Are you following me or not? There is one more traffic channel requirement, which is what? 4 to 3. Where? Can you fit it? You cannot fit it, which means what? I need to put a what? I need to use another what? Another wavelength, which is wavelength number 4, to support what? The traffic. Where is it originating? Where is it originating? It's originating here. And where it is dropped? It's dropped in here. Did you? No, I'm sorry. It dropped where? No, there is a typo here. 1 second. This one originates at what? 4 and terminates at where? 3. This one should be here. I'm sorry. This one should be here. Remove this. Did you get it or not? It's terminating at 3. It does not terminate at 2. Did you get this or not? Okay. Count the number of ADMs I need. First of all, did you understand what is mean first fit? It means what? This is the easiest way to do. You follow me? You start what? Channel by channel, channel by channel. You fit it in here. Okay. How many added drop max here? How many do we need here? 1, 2. So here 2. How many do I need here? 1, 2, 3. How many do I need here? 1, 2, 3, 4. Are you following me or not? This is 4. I'm not sure. Did you understand where the 4 came from? Did you get it? Do we need an added drop on lambda 1? Do we need an added drop on lambda 2? Do we need an added drop on lambda 3? Do we need an added drop on lambda 4? That's 4. Clear? And here, how many? How many? Also 4. Did you get where this 4? Question. Is this the same IDM or separate? Why? One of them is on what? Lambda 1. The other one is on what? Lambda 2. Did you get this or not? So I need 4. For a total of how many? 8, 11, 13 ADMs are what? Needed. Clear? No response. Clear? Okay. Now, let's see modification of this. Can we modify this? Can we modify this to eliminate the need for what? By the way, you notice the wavelength 4? Wavelength 4 is all what? Almost all what? Empty, almost wasted. The question is what? Can we rearrange these such that we don't need this wavelength? Did you get my point or not? We cannot do it if we insist that the channel remain on, the traffic requirement remain on the same lambda and the same what? Channel. Did you get my point or not? Let's see if you can help. Allow channel shift on the same lambda. Allow shifting the channels, but on the same what? On the same lambda. Let's see if you can help me. I want you to see what happened in here and what happened in here. Okay. The 1 and 2, this is the what? The 2 and 1. This so far is the same. Compare this one with the previous one. Let's put it together so that you can see. The first one is the same. You follow me or not? Okay. Next one is the same. Next one is the same. Next one is the same. There was no changes in the first one. Did you get this or not? Now, let's see if we can help. Next one. 1, 4, 2, 1, 4, 2, 1, 4, 2. You see this one is empty? Yes? What did I put in it? 4 to what? How many are there from 4 to 2? 4 of them. Where is the 4 to 2 here? Can you show me where is the 4 to 2 here? You see this one? You see this one? Can I support it here? This one here. Can I support it here? So what do I have? Look at it. 4 to 2. Now 4 to 2, it's what? This is on which landing? On which landing? Landing 2. I want you to see this. Do you see this one? Is it empty? Do you see this one? Is it empty? Can you support 4 to 2? Provided what? You change what? Channels within the same what? Land. You lost me? Did you lose me? You lost me here. And this will be in the test. So you need to be very, you need to understand it very carefully. Do you go back to the previous one? Is this empty? Is this wasted? Is this wasted? Could I have some, where is this one originating? At 4. Where is it terminating? At 2. Yes? In here, I could not use it. Why? Why? Because we have exhausted all the channels on this wavelength. Did you get my point or not? Okay. So where is the 4-2 here? Excuse me. Where is the 4-2 here? Here, in the first case. In the first case. This is the 4-2. Yes? Originating at what? 4 and terminating at what? At 2. Did you get this or not? Could I have brought this one? 4 to 2. Could I have brought it here? 4 to 2. This one, which was wasted in the first one. 4 to 2 here. Did you get this or not? But did I switch channels? I switch channels. I switch channel from channel 1 to what? Channel 2. But on the same what? On the same wavelength. Did you get this or not? Now what do I need here? I need to demux and mux to switch the what? the channels. Did you understand that or not? Within the same wavelength, I need to what? Demultiplex the channel and then what? Multiplex them again. Why? Because I changed the what? The channel within the same what? Within the same wavelength. Clear? No response. Clear? Okay. So I brought this one up. Yes? To here. Yes? And this or to here. Resulting in what? In this. Do I need the wavelength here? This wavelength. By the way, the remaining is exactly the same. Did you get my point or not? How many added drop mux do I have? Here. I have 1, and this is what? 2. 1, 2, 3. 1, 2, 3. 1, 2, 3. For a total of how many? 11. As compared to who? As compared? How many was? Huh? How much? 14? 13. But where is the chart? One second. I lost the chart. Where is it? Here. It's 13. Did you get this or not? Yes or no? I could have what? I eliminated this, but I needed to what? I needed to demultiplex the channels here. Do you understand or not? Why? Because I'm switching channels. Okay. Let's see if we can what? If we can save some more. By the way, you tell me, Professor, how we can save some more? Do you understand that we have to have at least 3 wavelengths? In other words, 2 wavelengths will not do the job. Do we agree on this? We can, because from the analysis, it shows what? It shows on each what? On each link, we need at least what? At least 3 wavelengths. So what are we trying to accomplish more? We are trying to see, can we reduce the what? The number of ADMs. Can we reduce the number of ADMs? So this one, allow the channel shift on the same lambda. Now, allow what? Changing lambda also. This is what is known as what? Repacking. Repacking, so that you understand what I'm talking about. Let's see if you can help me here. Do you see this one? This one? What did I change here? Look what I changed here. This one is still the same, which is what? 1 to 2, 2 to 1. I wanted to see this. In here, did we drop channel 3? Sorry, this traffic from 1 to 3. 1 to 3, which is 1. Did we need to drop it here? Okay, I wanted to see what did we do here. This is what? I moved, instead this one, the 3 to 1, I moved it where? Where is the 3 to 1? Help me. I moved it here. Did you get this or not? In here, where was the 3 to 1? On which wavelength was the 3 to 1? On wavelength 1. I changed it to what? Wavelength what? 2. So that in here, there is no wavelength, there is no traffic channel terminating at which node? Node 3. Okay. Let's see, you are losing me here, I can tell. Okay, do you see this one 3? This one is 3. This one and this one. And the 1, 4. Do you see the 1, 4? 1, 4. In here, the 1, 4 are in what? The 1, 4, we have 2 channels, are on separate wavelengths. Could I bring this one and this one, these 2, here, and bring this one in place of them. Did you understand what I just said or not? Why? But I'm not sure you understood why. In here at node 3, do we need an added drop mux? Here. Do we need an added drop mux? For which channel? For the one that is originating at what? 1 and terminating at what? 3. Only for that. Can I move this one to here, to wavelength number 2, and move the 141 and the move the 141 to take its place, and 142 to take the place of what? 141. Such that on wavelength 1, there is no termination at what? At node 3, which means I eliminated this guy. Yes or no? So what do? I want you to understand. This one here, by the way, is the same thing. But I need you to see what did I do. This, where is it? I bring this one, where? Bring, first of all, this one here. Bring this one, what? Here. And bring this one here. Did you get it? Yes? So what do I have? 1, 4. Did I mess up? No, actually, this one stayed here. I just moved this one here. I just moved this one to this place. You follow me or not? I did not move this one to here. See? 141 is still on the what? On the channel 4. I just switched those. This one and this one. I switched their location. Did you get this or not? What did I eliminate? I eliminated the need of what? Using how many added drop mux here? Can you tell me how many added drop mux here? Here is what? 2. How about here?
The time is 8
1
o'clock.
here. 1, 3, 2, 2. For a total of how many? 9. By the way, it could be even you might even be able to get it to 8 if you think a little bit about it. How to repack it. Did you follow me or not? Okay, but let me explain to you first of all here. Did you answer what we are doing here? Okay, so one more time. I brought this one 131 was where? 131 was here. I brought it to here, and then I brought this one to here. So this one is what? 1, 4, originating at what? 1, and terminating at what? 4. Yes? What is this? 4 to 4. 4 to 4. This is 3, 1. Since I moved this one 1 to 3, the 3, 1, I also moved it here. And who took its place? I moved this one to what? Here. After I moved this one to here, I moved this one also to here, and this one moved back to what? Here. Did you get this or not? So this one is now what? 4 to 4. Sorry, 4 to 2. Now 4 to 2, it originated at what? 4, and it terminated at what? 2. Yes? Now if it originates at 4 and terminates at 2, which means what? This is? Where is it terminating? Where is this one terminating? It is terminating here. Yes? Did I switch wavelengths? I switch wavelengths. Circuits on different wavelengths for different what? Segments. In other words, when I say the repacking here, you allow the switching of what? You allow the switching of wavelengths at the same time. See this one here? The 4 to 2, when it started in here, it cannot terminate here. Can you tell me why it cannot terminate here? It cannot terminate here because this one is already what? It's already used by 1, what? 4. This one is what? It's 4, what? 2. Yes? 4 to 2, 4 will be what? will be supported in here. So this one and this one, this channel and this channel needs to what? Needs to be on a different what? Needs to be on a different wavelength. Clear? Clear? You need to look at it carefully at home. Are you following or not? Notice, by the way, do we still have something left? Which means what? There is a possibility that you can even what? Improve by assigning those what? By assigning those channels in a different. Is there another channel? So rearranging to keep what? Rearranging those to keep the circuit on the same what? Channel. In other words, after you created this, in here, did we require that the circuit switches channel? Here. Circuit switch channel means what? Within the same wavelength, but you are switching what? You are switching channel.
Professor, there are 5 minutes left.
In other words, even you can improve on this by what? Let's see, what did we do here? Can you tell me what did we do here? Let's see. Can you see it? Okay, 1 second. Yeah. This is the 424. Do you see this 424? 424, I had to switch what? Wavelength. Where is the 424 here? Wait, where did I change here? 1 second. Did we change the first one? Which one? Second channel. What was it here? What was it here? It was 1, 2. It was 1, 2. I moved. See this one here? 4, 2. See this one? Going from here, I had to what? I had to switch to another wavelength. You follow me or not? 1 to 2 only needed what? Here. Only needed 1. Can I move this 1 to 2 here and bring this one here? Did you see this or not? Yes. To do what? For what reason? So that you don't need to switch what? Wavelength. Why I can move this one here? Because this one only need what? 1 to 2. So, and this 4 to 4 is the continuation of this guy. Where did this one started? Where is it terminating? Instead of terminating here, I'm going to what? I'm going to move this one. I'm going to move the channel here and bring this one. Not this one, sorry. This one. Did you get this or not? I will bring this one where? Where? I'm losing here. Where? Move this one to here and move this one to what? Here. Did you get this or not? By the way, did I eliminate the use of the ADM or the ADM is still there? ADM is still there, but I eliminated what? The need to switch what? Wavelengths. How many ADMs do we have here? Let's calculate. How many ADMs? 1, 2, 1, 2, 3, 2, 2. I messed up? Where did I mess up? Oh, jeez. I'm sorry. Where is it 2? Oh, yeah, here. This one, it does not show clearly. This? And where is the other one? This? This. Okay. So 2. What is the total? 9. Which means what? I did not improve on the number of what? ADMs here. But what did I improve? This one, I eliminated this one. Do you understand this or not? This is switching. This is switching. I eliminated it. By what? By moving. What did I do? One more time. By moving this to here and sorry, moving this to here and this one to here. Clear? Clear? Okay, you need to look at it at home carefully. And I will assign, not a homework problem, but I will make it extra credit for this weekend, something similar to this, for you to practice with it at home. Clear? I think I ran out of time. Did I run out of time? Operator? John?
Oh, yes, out of time now.
Okay, good. Okay, we'll continue next time. But did you get it? It's not that hard. It's not that hard, but you need just to concentrate a little bit. By the way, there are still empty stuff. You can maybe even improve. You can improve. By the way, if you can improve and you show it to me, I'll give you also extra credit. If you can improve on this, reducing the number of IDMs from 9 to 8. If you let me know, I will give you extra credit.
This is the end of WRED 555 on Thursday, April 24th, 2014.